And welcome, Mindsetters, to this session of Learn Extra Live. How you guys doing? I know you haven't seen me for a couple of days, but hey, anyway, we're back and we're here for some maths for grade 10s. I hope you guys have your pens, pads out, and you're ready to make notes. Right here with me, I've got Mr. Iti, who's taking us for the session. Mr. Iti, what are we doing today?
Yes, we continue with where we left off last week. Last week we did statistics, but we're doing a central tendency of data. Today we will basically continue with graphical representation and dispersion of data.
Okay, no problem.
All right.
Well, Mr. Iti? Well, Mr. Iti makes his way there. Mindsetters, I'm going to tell you, the same drill we always have. Make sure you get on the Facebook page. If you have any problems, if you're lost anywhere, make sure that you guys put your questions up onto Facebook. So I can take your questions and then hand them to Mr. Iti. We will then help you guys out. But as I always say, if you do not tell me, I can't help you. And on that note, yes, so you make sure that you get on the page. Here are some awesome prizes that I'm always trying to get hold of. Like, let me flip this around. Yeah. I'm always trying to get rid of these things. So my guys, or I'm not get rid of them, but hand them to you. But Mindsetters, I want to tell you this. Make sure you post on the page so you can get this awesome Casio calculator and this awesome labeler. And on that note, make sure you get on the page and chat to me. And I want to send a quick shout out to Liberty. Thank you for sponsoring. And on that note, this is where I hand over to Mr. Iti, who's going to take it away. Take it away.
Thank you very much. Greeting to our viewers at home. Yes, last week we stopped where we were doing a graphical representation of data after basically learning that there is central tendency of data. So what we're going to do today is basically get to see how data is dispersed and basically compare different types of data as well. Okay, and I'll start off by, remember there were some quantities that I mentioned last week, typically the quartiles and the minimum and the maximum of data, and those we are going to use to, to basically look how data is dispersed. All right, I've got here a data comparison. I can just pick a pen there. Data comparison today is what we are doing, and measures of data dispersion. So we will be looking at the range of data, in other words, from the minimum value to the maximum value. And we will be looking at the interquartile range. Now, there you'll notice that we're still talking about the quartiles. So the quartiles that we're interested in will be the Q3 and the Q1. So when you take away the Q1 from the Q3, you get the whole the range of the quartiles, the first quartile and the third quartile. Then what you'll notice is we've got now the 5-number summary there. So far we've got 1, 2, 3, 4 points. And another point that we have interest in is the median. We discussed that last week. And the median becomes the 5th number, which we can present so that at least it gives you an idea. It gives you an idea about the spread of data. All right. If I look at this, I actually worked out a quick summary of how you can determine the quartiles of data. If you have data that is a multiple of 4, take away 1, typically 8 minus 1, which is 7, or 12 minus 1, which is 11, 16 minus 1, 15. What you're going to have is what I call a full position. A full position. And for all the quartiles, you're going to have a full position, typically position 2, position 3. For 7, for instance, if we have, let's say 1, 2, 3, 4, 5, 6, 7. The median or quartile number 2 of those positions will be at position 4. And the first quartile will be at position 2, and the third quartile will be at position 6. So there's Q1, the position of quartile 1 will be there, position of quartile 2. Remember, this is the median. Then position of quartile 3 will be over there. So like I said, this number, it's a multiple of 4, take away 1. In this case, it was 4 times 2 minus 1, which is 8 minus 1, and that gives you 7. So our n is equal to 7, and when you have that situation, it's a full position, full position, full position. Now, if you have data that is exactly a multiple of 4, like 4, 8, 12, obviously. So you are going to have what I call half positions. Half positions, I have represented them using the letter H there. H, H, H. All of them will be half positions. All right? That's for 4K. And maybe we should show an example there. Typically, if you have 1, 2, 3, 4, 5, 6, 7, and 8, this position divides this data into equal data points on the left and the right. And that becomes its position 4.5, and that's quartile 2. That's position 4.5. So that's what I mean by half positions. And if we go to the left of that and want to divide the data on the left of that median into 2 equal halves, so 2 equal positions, then we get quartile number 1, and that is 2.5 as a position. And to the right of the median, you will go to the middle of 6 and 7, and that's quartile 3, and that's position 6.5. So those are half positions. I've represented that with the H's. And if you go if you increase your data from a multiple of 8 and just increase it by 1, what will then happen is your first quartile will be in a half position, your second quartile in a full position, your third quartile in the half position again. So on and so on. If we move on to 4K plus 2, the full position for quartile 1, then the half position, and then full position. I believe this table, if you can write it down, it will help you. It will help you at least as you do problems. You should be able to target your quartiles according to their position, the size of data. Okay. So if I move on to an example where we work out the quartiles, for instance, what I have here is, okay, like I said, today we will be doing data comparison and a measure of dispersion. But there are all these, statistics that we have to work out. Typically the median, the first quartile, the third quartile, like I've said, the interquartile range. I have taken this set of data from some book, and if we want to work out the median in this case, we'll have to, let's take question number A. The data that is given there says 1, 3. Now, we will have to put it in order. So that is 1, 2, 3, and then you've got 4 and 4. Next is 5, and then you have 7, another 7, then you have 8 and 10. All right? How many do we have here? That would be 2, 4, 6, 8, 10. Now, like I said, this is now position 4K plus 2. It's a multiple of 4 plus 2. All right? That being the case, it means our median, in fact, in this case, we can actually look at it quickly for this side, for that side. Now, if you take 1 again from each side, you end up in a half position. So your data will actually be in position 4.5. And indeed, in this case, the data that we have is such that that is the value, because it's between 4 and 5. All right, that's now the median, quartile 2. Now, the other quartiles. If we go back to what I said in that table, this is now this case, okay? The median was in a half position. We expect the first quartile and the third quartile to be in the full positions. All right. So if we look at this data right from the middle, going in that direction. So 7, which is this point here, is separating the data on the left into equal parts, 2 there, 2 there. And that becomes your Q3. Q3 is equal to 7. And on this side, yes, we look at it from the middle to the left, and 3 becomes a full position again. So that's what I mean, in that table. So that's a full position for Q1. Q1 is equal to 3. All right, so we found the first quartile, the third quartile, and we also found the first quartile because we need to find the interquartile range. So our interquartile range for this problem, for this data, will be, let's represent it as interquartile. Interquartile range will be your Q3 take away your Q1, which becomes 7 take away 3. That is your interquartile range. All right, that was the first data. Now let's see how many we have here. Let's rearrange it as well. If I extend that. All right, so what we have, starting from the lowest, over there, the lowest is 8. So we've got 8. Next will be 7. 7, 8, 9. So that is 7, 8, 9. Then you've got a 10 as well, followed by 11, 10, 11. Then followed by 13. There is no 12. 13 followed by 14, then 15. 13, 14, and 15. Next to that will be the 16, another 16. There are 2 of them. 16, 16. And next will be 18 followed by 20. 18, then 20. 20 is clearly a multiple of 4. For a multiple of 4, if I take you back a bit, for a multiple of 4, that is the 4K, all of them will be in half positions. All the quartiles will be in half positions. All right? There we go. If you divide 20 by 4 to get 4 parts, you will get 4.5. So, 4, therefore, between 4 and 5, you get your Q1. The next will be the 8, obviously. Oh, hang on. We said we've got how many? We said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? Just to correct a correction there. 10, 11. All right, so 12 data points. 12 data points divided by by 4 gave us 3. So the position will be 3.5. Okay, and that becomes quartile 1, which is 9 plus 10 divided by 2. And that gives us 9.5. Okay, and to get the second quartile, 12, remember n is 12. I think I need to write that down. So if you divide 12 into 2 parts, you get 6. So 3, 3, right there. You get quartile number 2, which is 13 plus 14 divided by 2, and that is equal to 13 and a half. Okay, so next will be quartile 3, which will be after 9 points. So that would be quartile 3. Quartile 3 is equal to 16 plus 16 divided by 2. Anyway, that gives us the same value. Right, so what did you notice about the positions? We said this is position 3.5. This is position, I think it's 6.5. That position, and that position was 6, 9. So that's 9.5. That was the position of the third quartile. So that table begins to make sense. All right. We've got the 3 quartiles, and one of them is the median. So we've got the median, we've got the first quartile and the third quartile. The interquartile range for this one will therefore be, interquartile range will be Q3 take away Q1, and that is equal to 16 take away 9.5, and you get what's that? 6.5. That becomes your interquartile range. All right? And the third data, if I count how many they are, I'm sure you've seen how the process works here. This one has got how many? 2, 4, 6, 8, 10, 12, 14, 16, 18. And again, it's more like the first one. The position is 2 less than a multiple of 2 plus 2 units. All right. Right. Any questions so far, Ty?
So far, haven't
cruising?
had much. We're still cruising. I think they're just more watching and paying attention. But yeah, I think we're still good to go.
Okay. No, that's great. All right. The third example that I have there, I think I'll leave it for you to do. It's the same process. But then, if I look at that again, yeah, that's what we had to find. The median, the first quartile, and the third quartile, and the interquartile range. I said we are talking about comparing data and the measure of data dispersion. All right. If I move to comparison in the next question, you will see that you have been given 2 sets of data. One is called class A, and the other one is class B. And this is a mathematics test, and those are just the marks out of 50 in each case. All right. And this question, I think we can carry on after the break.
I think so,
right? Yeah.
All right, so mindsetters, make sure you do not disappear. Remember, stay on the page, keep chatting to us, let us know what you guys are thinking. If you're lost and if you need help, post it on the page so I can get those questions to ET. But for now, we're going to see you after this break. Cheers.